All right, 1.8, day 3. Last thing we need to cover is this last learning target. I can use combinations. Okay, so some of these operations down here, and or compositions of functions to model and solve real life problems. I'm going to focus on just 2 of those today. Okay, so let's jump ahead to example 16. All right, so this first function gives us the number of bacteria in a refrigerated food based on the temperature, right? We know if we take something and we set it out of the fridge, as the temperature starts to increase, the number of bacteria, it's kind of a breeding ground for bacteria, right? It's going to start to multiply and increase. So this relates the temperature of the food in Celsius and the number of bacteria. Okay. Next step to this, when the food is removed from the refrigeration, the temperature of the food is a relation to how long it's been left out. Okay, careful, there's a couple T's here, so that can be confusing, but lowercase t is the time in hours. All right, so it's kind of a 2-step process, right? We take the food out of the fridge, time is elapsing, so as the time elapses, what happens? The temperature goes up. As the temperature of the food goes up, what happens? The number of bacteria increase, cause and effect. Okay, so by creating a composite, we'll actually skip this process and make it 1. You'll see what I mean once we create this composition. So find the composition of this and interpret its meaning in context. So here we go. So since lowercase t is next to capital T, that goes first. Let's put that in the belly of the function. Write this down. Okay, so this function has to go into function n. So this here is going up into this function, right? In these 2 spots, here and here. I'm just going to kind of push you along and then let you do some of the math because I just want to do one of these. This also is a lot like 58 in the book, and then it's also on your review sheet. All right, so it's going to look like this. 20, instead of t squared, I have to plug in this function 4t plus 2. And then it says minus 80t, so function goes in. Okay, plus 500. All right, now we've been through these algebra steps before. These numbers are just bigger, that's all. So we're supposed to expand and take care of this exponent first before we multiply by the 20 and the 80. Just wait on those. Okay, so this is where I'm going to give you a moment to get a little ahead of me, but we're going to expand 4t plus 2, 4t plus 2. Focus on foiling that first before we multiply by 20 and 80. Okay, I'm going to pause. You go ahead and try that. Okay, so here's the algebra to check. When we FOIL this correctly, this is what we get. Distribute the 20 now, and I get these 3 terms. Okay, now I can also multiply the negative 80 through, and I get these. Okay, and then just combine like terms. These 3 20s canceled out, so they're gone. Okay, now I could express it like this, but now the capital T is kind of out. We're skipping that process of temperature. This now relates lowercase t, the time that the food has been taken out of the refrigerator, and the number of bacteria. So when it says interpret the meaning, that's what they're talking about. Writing down exactly what I just said. So this relates this function. So the function relates the time food is out and number of bacteria. Okay. That's interpreting the meaning of this function in context. All right, part B. Now they may give you the input value, they may give you the output value. You just gotta, that's why it's important to understand this function. Find the time. T is the unknown then. They may give you the time on a different problem. They might say that half an hour has passed or an hour has passed. plug it in and figure out the number of bacteria. But in this case, they're giving us the number of bacteria. So we're going to plug in 2,000 on the left side. Okay, so take 2,000, plug it in here, and we want to find the time. Okay. All right, this is a pretty, sometimes quadratics get messy. This one's not bad, just big numbers. When we just have a t squared term, we can use the square root method. We just got to get it by itself. So move this over. It gives me 1580 equals 320. One more step to isolate t squared, so divide by 320. Continue over here. So I get t squared equals, I punch this in my calculator, that number, and it's 4.9375. That quotient. All right, just take the square root of both sides. We'll have our answer. So boom, boom, t equals, now we should do plus or minus, and it gives me about 2.2. All right, but we're talking about time. So with an application, we're going to throw out the negative, and we're going to say it takes 2.2 hours to generate or create 2,000 bacteria. 2.2 hours to create 2,000 bacteria cells. Okay. All right, so there's one application that we're doing. Just to recap it, we had a function that related time to temperature, and then temperature to number of bacteria. So by plugging that in, we were able to kind of shortcut the process if we knew the time that was left out. Because now we have time to number of bacteria. Okay. So good application of where composites can be used. All right, let's go ahead to the next page. We're going to skip 17 for now. It's a decent one. It's a little bit like our warm-up, but don't worry about it. It's not going to be quite like that in our quiz. I want to focus on 18. And we're really just going to focus on A. And once we create A, sometimes we'll be asked to use the function, but we aren't going to focus on graphing this. Okay. All right, so go ahead and read that to yourself first. Okay, so remember revenue, if you're not familiar with that word, that just means the money you're bringing in, right? So cash coming in. So money coming into the business, okay? Cost, there's money going out. All right, so profit is the difference of these two. This is the money you get to keep for a business. How profitable a company is you take your money generated, but you don't always get to keep all that, right? Because you got to subtract your costs to get your profit. So that's what they're asking us to do. Write a function P that represents the profit. Okay, so we're going to say P equals revenue minus cost. So 330 plus 3.2T, subtract the cost. Okay, this is a function of time, so they may even represent it like this too. Profit is a function of time, whichever. All right, so this is just one of these. It's not a composition, it's just a difference function. So go ahead and distribute the negative, rearrange it, and get your profit function. Go ahead. Okay, so don't forget that minus. We'll change all these signs here. And then when you rearrange it and put it in order, and there's our profit function. Okay, two good follow-up problems to this. It's also on your review, but if you want a couple more, just for your reference, number 58 and 62 are like these in your textbook. All right, so feel free to get that extra practice if you feel like you need it. And like I said, it's also on the review sheet. All right, that's it for 1.8.